All right, don't forget the whole course is kind of short. All right, so I was talking with some of the other teachers yesterday, and they wanted us to remind you that we don't have a whole lot of time, you know, to get and grade these things. So it's really easy to kind of put it off. You know, it's like, I'll turn it in next week. But by the time next week comes around, remember that it does take a little bit of time for us to get these and grade these and enter them. And I think they want kind of like a progress report at the beginning of next week. So that is going to take some time, right? So don't hold on to these packets. I should already have your 1 and 2 packet already. And I sorted through them, and I only have a handful of each of them, and they're mostly from the same people. So please, please, please start turning in your packets. Okay, nothing good is going to come if you wait over it. So let's go ahead and go over the next part, which will be parallel line proofs. So how can we prove that we have a set of parallel lines here? So what they want us to do is prove that J and K are parallel with each other. So in this case, we have our transversal here, which actually it does not look like it is named. But let's see, given that 4 and 7, so 4 and 7 are supplementary. Now, in that case, we don't have any of the converse to tell us that, you know, there is no, well, actually in this case, there is no real relationship with it. But what we could do is we could look at, say, 7 and 3 and ask ourselves, would they be the same? Well, if they are the same, then we know that these two lines would be parallel. So there's actually a couple of other things we could do too. Like for instance, if we know 4 and 8 are parallel. So let's see what, and you don't have to follow the exact same one that's given here. All right, so, I mean, the steps, there's like 2 or 3 ways. I'm looking at this and there's like 2 or 3 ways that I can think of that I can do this. So let's see, 4 and 7 are supplementary. Okay, that's given. That means they add up to 180 degrees. And remember, your reason number 1 is always given. Okay, so I know some students, they like to put the first step up here so that linear pair would have been here, but no. Okay, first step is always given because nothing happened to it. You haven't done anything besides rewrite it over here. All right, so let's go ahead and see what the next thing they say is, and that is 6 and 7 are congruent. I'm sorry, are supplementary, 6 and 7. So 6 and 7 are right next to each other on this line. And again, these lines do not bend, change direction or anything like that, right? They just go straight. So if we can see that this is all one line, then that would mean that 6 and 7 are a linear pair. And that would also mean that they are supplementary. That is the definition of a linear pair. Number 3, step 3, I should say. Angle 4 and angle 6 are congruent, so 4 and 6. So congruent supplement theorem. So 4 and 6. In that case, it would also be alternate interior angles as well. And therefore, we have proven that J and K are parallel by alternate interior angles converse. All right, so again, 4 and 6. So that way we'd know that those two lines would be congruent. Okay. All right, so let's go ahead and go to the next one here. And I'm going to kind of move along a little bit. They're not really a whole lot of steps on each one of these, but there is still quite a bit of writing on these. So I'm going to move up a little bit more. So given that A and B are parallel, so A up here and then B are parallel, well, oh, yeah, okay, that's a second given. We have another information that is given to us. So 2 and 3 are congruent. So just keep in mind that these two are the same angle in degrees. So A and B are parallel. Okay, that's given. And angle 2 and 3 are also given. We want to prove that angle 1 and angle 3 are the same. So how do we prove that angle 1 and angle 3 are the same? Well, okay, so 1 and 2, angle 1 and angle 2 are the same because we know these are parallel, A and B are, and this would act as a transverse. So that would mean that 1 and 2 would be alternate interior angles. So again, interior meaning they're both on the inside of these parallel lines, and alternate meaning they're on different sides of the transversal. So if we know that 1 and 2 are the same, and one of the givens is that 2 and 3 are the same, then transitive property would say that 1 and 3 are the same. See? Not so bad. Again, it's just a matter of kind of proving it. I mean, looking at this, you could probably immediately tell how it is. You know, you could probably tell that 1 and 3 are the same, but you got to prove how you know that. All right, I'm going to go ahead and move on down to the next one. All right, so given that angle 1 and angle 7 are the same, well, okay, so now we know they're the same. That's already right off the bat alternate exterior angles. So that's one of the first things that we can do. Prove that angle 4 and angle 8 are the same. So 4 and 8. Now those would be corresponding angles because they're both the lower left of each of their intersections. All right, so let's write our given. And again, the first reason is always a given. We can tell that L and M are parallel because of the alternate exterior angles. So that was exactly what I said. I didn't even look down here. I just looked at it, and the first thing, alternate exterior angles. And if 4 and 8 are on the same side, that would mean that they are corresponding angles. So corresponding, again, they're both the lower right of each of those angles. And in this case, we already know they are parallel. So if we know L and M are parallel, we can draw any of those converses with it. Whereas on the first one, it probably took a little bit, took a few more steps because, well, in that case, we already kind of knew that, we didn't know that they were parallel. So when you don't know they're parallel, usually it's a little bit more difficult to prove that. But if you know things are parallel, then that's usually, it's usually a little bit easier because you have more information to draw on. All right, so let's go ahead and go on to number 4. So again, let's look at what we have. So 5 and 8. So this one and this one. So 5 and 8 are supplementary, which means that they will add up to 180 degrees. All right, so that would mean already that they are consecutive because they're on the same side, exterior angles. All right, so let's write our given. Okay, that was our given. Therefore, we would know that they would be parallel because of consecutive exterior angles, converse. Right, and they have to be the same because if 8 will fit right where 6 is, if like a pizza, you were to take it out and put it right there, that means that they would match. So if I were to take 5 and 7, that would also be the same as well. So using consecutive exterior angles, we can prove that angle 3 and angle 6, so 3 and 6 are equal because now for sure we know they're parallel. Okay, we know those two lines are parallel. Alternate interior angles would say that, yeah, that would prove those two angles are congruent. All right, so there we go. And I think there's like a few more on these. I looked ahead a little bit. Actually, I can look a little bit ahead without going anywhere. So I'm pretty sure there were 3 or 4 pages to this here because we covered the first one with parallel lines and proving they are parallel. And right now we're on parallel proofs, and it looks like we covered the first page. And yeah, there are 2 more pages. I'm gonna go ahead and move down to the next one so you can start copying it. I left that one there just a minute or 2 so you can start copying it. I'm gonna go ahead and move this down there. That way we have more in view. And it looks like there's actually a lot of pages. Goes up to 15 of these problems, and that would be 1, 2, 3, 4. So there's 4 pages of this actually. So 4 pages in we got about 30 minutes left. All right, and again, I'm gonna give you a minute or 2 to copy those down so that way you're not, you can listen instead of trying to write. I guess I'm going to double check the attendance. We're still in first hour, by the way. We're still in first hour. So if you have another first hour, you know, you should probably also still be there. All right, pretty good attendance today. The people I expect to be here are here, which is good. But there's also one other thing, I guess, while we have this kind of break. Well, I guess I have a break here. I also wanted to go over too, and that is using the independent student learning time. So, independent student learning time is not free time. Okay, it's not free time. Like I've been asking you, if you have any questions, you know, don't be afraid to ask them. If we have time in that independent student learning, that is where you would ask your questions. So, you know, you don't have the excuse of, well, he doesn't help me because you're not asking. And also but that's not the thing I wanted to talk about. The thing I wanted to talk about is that you are required to be there. So today, actually, I had about 3 people leave and not come back until we started this lesson. You are required to be here the entire time, so do not leave, all right? Because I'm suspicious when I get a nothing on the, when the Zoom, like, when I'm not getting any sort of interaction, because that makes me think that you just turned it on and, you know, you're playing video games somewhere, so please don't do that. If it comes to it, you know, I might end up having to do something else to make sure that you're still participating, to make sure you're still there. And I guess it wouldn't be that, you know, we've already had half our course, so I wouldn't want to have to change anything on anybody. So please don't just turn on your Zoom and walk away. And I think for today, lates were pretty good. I didn't have any late people here for this class today. So yeah. And again, if you're late over a certain amount of time, then it's going to count as an absence. So please also don't be waiting to turn it on, right? Set an alarm, do something so that you know when the class is. All right, so I'm going to go ahead and go into number 5. That should give you at least enough time ahead. Well, actually, I don't know if no, I probably wouldn't have enough time to do that either. So I'm going to go ahead and just go into number 5. Like I said, we've already used up a couple of minutes, about 15 minutes, and we've only covered the first page. So we'll go as far as we can. All right, so given C and D are parallel, so that means these sideways ones, these 2 sideways ones, we know for sure they are parallel. We also know that 1 and 7, so up here and up here are congruent. So we know angle 1 and angle 7 are the same amount in degrees. So what we want to do is prove A and B, those are the 2 up and down direction ones. We want to prove that those are parallel. So let's put our givens in there. So we have 2 sets of givens. We know C and D are parallel. We know that angle 1 and angle 7 are congruent. So that's another given. So we have 2 givens. So what did they do? So 3 and 1. So 3 and 1, right? Because we know these 2 are parallel. And we know that 1 and 7 are the same. So let's try a 1 and 3. So they use corresponding angles to show that those 2 are congruent. Well, if we know those 2 are congruent, we know that these are parallel, then 1 and 3 should also be the same. So that's transitive property, right? If these 2 are the same, then that third one should be the same if these lines are parallel. So that's why they use transitive property in this case here. And the last step, A and B would be parallel because of corresponding angle converse. So A and B corresponding. So what do you call it? 1 and 3, because we know that 1 and 3 are the same. That is corresponding angles. So corresponding angles should be congruent. And since we know that they are parallel, C and D, then that has to be true. So there you go. We did that one again. Let's go ahead and move on to the next one, number 6. So number 6. So we're using this figure here. We know that J and K are parallel. So that takes care of that. We want to prove that 1 and 7, that's these two here, are supplementary. So J and K are parallel because that is a given. So we know that. They told us that. Angle 5 and angle 7 are corresponding angles. So again, we already know that these are parallel. So corresponding angles, yeah, that makes sense. That's one of the things that if you know it's parallel, then you can use any of those reasons that you have. And again, there's always more than one way to do these. And it doesn't even have to be in this order. All right, it just has to make some kind of sense in the order. So angle 5 and angle 7 would be the same because that's the definition of congruence, 5 and 7. So we know they're the same. And pretty much all they did, whenever they say definition of congruence, well, they remove the congruent and turn it into a regular equal sign. And then they put measure in there. So in order to be able to do math stuff with it, we have to take that thing off and be ready to, again, do math stuff with it. And then the next thing they said is that 1 and 5 are supplementary because, again, they are a linear pair. They're right next to each other. And they're both laying on straight lines. So that is the definition of a linear pair. So we know that those would also equal up to 180. And it looks like that's what they do right here. So angle 1 and angle 5 also add up to 180. That's the definition of a supplementary angle. So what we want to do now is say that the measure of angle 1 and 7, so 1 and 7, remember those are the ones we're trying to prove are supplementary. And since we know that they're already on a set of parallel lines, well, we can substitute it out. We can say that 7 and 5 would be the same. So we'll just plug it in. And just like a pizza, if I were to take this number 7 pizza slice out and move it over, it would fit right in there with number 5. And again, we already know they're parallel, so it should fit. No reason it shouldn't. Therefore, we know that angle 1 and angle 7 are indeed supplementary. All right, so I'm gonna kind of go a little bit down because I know some people might still be working on that one. So I'm gonna go ahead and leave this one in view while we get ready to cover this one. And let me see how I'm doing on time. Not bad. Gosh, stretch. Let's see, what should I do for lunch today? I still got food from yesterday, but I got pretty bad heartburn from it. Don't know if I should eat it or if I should leave it. But then I did pay for it. And not eating it would be like losing money. But then eating it would also be like losing money because I didn't enjoy it. So should you eat something you don't like just because you paid money for it? Which is worse? All right, so anyway, let's go ahead and get ready to go on to number 7. And like I said, I'm trying to give you guys enough time, but it's always kind of hard to judge writing speeds. And in these cases here, there is a lot of empty space. And that's why you're seeing the whole thing, so that way it just goes a little bit faster. Okay, so let's see. Given that line AB is parallel to CD, so AB, that would be this top part here, and CD is this bottom line here. So it says they are parallel. So we know that's true. And it says measure of ABC, so ABC, so that's the middle part here. So this part here is the same as ADC, so that'd be this part right there. So we know these two are definitely congruent. What we want to do is we want to prove that AD, that's this one here, is parallel to BC. Now we know that these two are the same, and it seems like it would be pretty easy to just go with that. But again, we got to do a lot of this proving stuff. So we start off with our two givens. CD and AB are parallel. ABC, those two angles that I pointed out, would be the same. So anyway, let's just go to step number 3. DAB, so DAB, and ADC, so ADC, are supplementary. So they're talking about this angle and this angle. These two would be the same. Now again, these are straight lines, and we know that these ones are parallel. Well, we can use these two here to use consecutive interior angles because they have to come out to 180. So if we know this one, then we should know this one. Or sorry, consecutive means that they're on the same side. Oh, I pointed to the wrong one. Consecutive, same side, interior angles. Anyway, so since we know that these two would equal to 180 degrees, they are supplementary. Measure of DAB and ADC would also be 180 degrees. So by substituting out one of these, so they both go with DAB, but they compare to different angles. So ABC would be this one up here. So this one and this one should also equal to 180. So just by substituting it out, we know that it should work out because that was one of our givens, is that these two are the same measure. Now let's see, DAB and ABC are indeed supplementary. So these two are supplementary, and these two, it'd be a lot easier if I could mark on this. So again, man, now I'm gonna have to pretty much go over the whole problem again, even if I do that. But they were again saying this and this are the same. And the second step would be something like, well, if we know this and this are the same, that's where they used that substitution property here. So the red pair would equal 180, the blue pair would equal 180. So therefore, DAB and ABC would be supplementary, and that means that AD and BC, so these two here, would also be parallel. And that's about halfway done with this so far. It's taken about an average of 10 minutes a page. So let me think about pacing. I think that might be enough. But I did give you time to write this one, so I'm going to go ahead and move on from here and move on to the next page. So it looks like we have quite a bit more because there's one and then there's two more. So I don't know if we're going to be able to get to that third one. We might have to do that one during one of the other independent student learnings if we have some time. I'm not sure if this is too far out. I'm trying to play with the Zoom so you could see a few more things in there. All right, so like right now, we don't need to look at this little tiny diagram. All right, just get these parts down here. And then when we cover it, then we'll be using the diagram and the steps. So just try to get this down, then we'll go over it. And again, it's about 10, 12, and I'm pretty sure we're gonna, I don't want to say anything just yet, but we might have to be prepared to just make this one the last page. Oof. Ugh. Let's see, maybe about 3 minutes. That would be about 10:15. And in about 1 minute, I'm going to go down to the bottom two so that it's going to show 9 and 10. So in the next minute, at least get number 8. All right, that would be about a minute. So I'm going to go down. You should at least have number 8 done. So there you go. Oh, well, actually, I can show most of it. Okay, it ends at 7, so that's definitely all of it. And again, we'll be here for the next 2 minutes or so. Oopsie. I'm good. My sister's going to be coming for a visit today. Darn, that means I'm going to have to go home. So I don't remember if it was this class, but I think I told what happened with my weekend. I went down to Phoenix to go help my sister move, and she had a lot of furniture, and she's moving into a much smaller place, so she doesn't have room for all the furniture, and she was going to throw some of the furniture away. So I was like, well, why don't I just keep it at my house? Because like my house is the kind of place that has like wire spools for furniture. So anyway, she's going to come down to look at the furniture and stuff. All right, so it's about 10:15. I'm going to go ahead and get started. And I'm thinking this will be the last page because I don't think we can really do a whole lot more here. Let's go ahead and go over these here. So given that R and S are parallel, and S and T are parallel, RS, so these two here, these first two are parallel. We know that ST is also parallel. We want to prove that 6 and 7 are congruent. And again, that's pretty easy because if you have 3 parallel lines, they are definitely going to be all matching angles. So let's see. We have our two givens, angle. R and S are parallel, S and T are parallel. All right, so if we use transitive property, right? So R to T, because they're both compared to S, they're both parallel to S. Since R and T are both parallel to S, we know that they're both parallel to each other. So just a simple transitive property of parallel lines. Or you could just say transitive property as well. You know, I'd probably be fine with that. And since we know that R and T are definitely parallel now, we know that 6 and 7 would basically just count as alternate exterior angles. So, okay, that one was a pretty easy one. I gave you some time, so I'm gonna go ahead and move away from that one and let's move to this one here. So given that 5 and 16 are supplementary. So 5 and 16. Looks like we got a lot of stuff going on in this one. I'm not sure how your graphics are on your side, so I'm going to go ahead and zoom in a little bit more here. 5 and 16. So 5 is up here, and 16 is up here. So we definitely know that these two are, they equal out to 180. So if I were to take 5, I could swap it out for 13, and then I'd have a linear pair, or they would be supplementary as well. 5 and if I replace 5 with 13, or if I replace 8 and 16, if I were to replace 8 and 16 and switch them, they would still be supplementary. What else do we know about this? 5 and 16, if they are supplementary, that would mean that they would be consecutive, right? Because they're on the same side, exterior angles. We also know that so the second given, and that's this one right here, is 2 and 18. So I'm going to move this over just so we can see a little bit more. So 2 and 18, so that's this one and this one here are congruent. So it's telling us that these are congruent. So we know that P and R would be parallel. So that's the definition of a parallel. All right, so let's see what they're, so I kind of told you everything we have to work with. So let's see what they're doing in order to prove that Q is parallel to R. Okay, so Q and P are parallel. Besides the givens, we know that the consecutive exterior angles converse. So that's kind of what I pointed out. We know that 5 and 16, if they do add up to 180, that already proves that those two are parallel. So what we can do next is look at line P and R, so P and R, because it told us here that 2 and 18 are congruent. That again already proves by corresponding angles converse that P and R are indeed parallel. And you could use transitive property, because using these two, we know that those P and Q are parallel. Using these up here and down here, we know that those would be parallel. So transitive property is how they got that. So the last step for that one would have been transitive property. And it looks like we're done. That was it. We know that Q is now parallel to R, because if we look at what we have here, so again, Q and P are the same, P and R are the same. Since they're both parallel to P, then that must mean they're both parallel to each other, Q and R. So going from here to there. And again, transitive property seems like it's confusing because, well, actually, in order to do transitive property, you need like one other step, sometimes two other steps to prove it. But in this case, just, yeah, I can understand it's tricky, but it's actually not really that tricky. It's just sometimes it requires one or two steps to get there first. Okay, I'm gonna go ahead and move on down, and that's gonna be the last one for this page. And again, it takes about a little more than 10 minutes for each page, so I don't think we're gonna be able to complete this one here. And I'm not sure, well, I'm gonna zoom in on this one a little bit more. Just to get it a little bit larger on your screen. Okay, because I don't really know what screen you're watching this on. You may be watching it on your phone, where you have a little, not a very good definition. Okay, so let's see. Look at our givens. 1 and 7 are supplementary, so 1 and 7. So if we were to swap 5 and 7, that would be supplementary. It would still be a linear pair. If I were to swap 1 and 3, both of these would be also supplementary. Now there's no relation between these. There's no there's none of the things that we have that we covered that says this is going to be that or anything like that. So at this point, we actually don't even know if A and B are parallel, because again, there's no already predetermined relation or definition that we have that would say that those are parallel. And in fact, that is what we are trying to set out to prove. Because if we can prove that those are the same, Well, let's just go ahead and go with it. So 1 and 7 are supplementary. Okay, that was our given. And I said that you can swap them out. So definition of adding 1 and 7 to be 180 is the definition of supplementary angles. And when they do that, again, all they're saying is they're turning it into math stuff. So and becomes plus, which is just basic algebraic expression, you know, like I have, let's see, what could I use? Well, the only thing I have right here is this jar of paint. So I have 2 ounces of white paint and 2 ounces of this yellow paint. So this would say that if I put them together, I would have about 4 ounces, right, of paint. So and is just a word, another word for plus. 1 and 7 stay the same, and we replace supplementary with 180. Again, all we did is get ready to do math stuff with it. So now we set it up. The next thing they say is 1 and 6 are vertical angles, which is true. They're right across from each other. And we know that vertical angles have to be congruent. That was one of the other things. So vertical angles are definition of congruent. So they do the same thing, definition of congruence. When they say definition of, that just means, again, take 1 and 6, take out the congruent and replace it with an equal sign so you can do math stuff with it. Now 6 and 7 are the next ones that they have here. 6 and 7, by substituting them, because remember how I said that you can flip some of these? So it looks like that's what they did. So by substituting in 6 and 7 and adding them together, you would get 180 degrees. And I can think of another way to do this. This is probably not what I would have done if I had to do this problem, but it might work out a little bit easier somehow. Anyway, 6 and 7 are supplementary. So 6 and 7, that's these two here. That is the definition of supplementary angles. They're also consecutive interior angles as well, which actually it looks like that's what they said right here. So they're trying to get these two so they could use the consecutive interior angles converse. So that would mean A and B are parallel, if we know that for sure. And we only have about 5 more minutes, so I'm not going to be able to cover the next page. But like I said, if we have some time during this, well, I don't think we have any more student independent learning time today. So I'm going to go ahead and I think, I'm trying to think, you'd probably be done with this one. And I'll give you another minute or so to do this one. And actually, I'm probably going to leave the Zoom open actually for the next page. So I'm going to leave the Zoom open. You can go ahead and look it up, see what you have to work with and all that stuff. And then for lunchtime, which is going to start in a few minutes, you can go ahead and whenever you're done and ready, okay, whenever you're done and ready, you can go ahead and just log off on the Zoom. But I will leave it open over the lunch break. So yeah, you'll have time to work on it. All right, so hopefully everybody got this one here, because I'm gonna move down here in a minute. Maybe another, maybe I'll do it like 30 seconds. And I'm gonna double check my attendance while I'm at it as well. Again, pretty good attendance today, but we just got to make sure we stay through the student independent learning, except for now. Actually, you know what? Darn, I almost made that same mistake again. Why did they change lunch? Why did they change it to 10:30? I mean, why can't they leave it at 10:30? All right, so I just forgot actually that we are not going to have lunch now, and that we are going to have to go to second hour. So I'm going to go ahead and leave this up for the next 4 minutes. Whatever you get, you know, is what you get. So that's going to be pretty much it for our lesson today. Maybe I can move down a little bit more. But yeah, we're gonna have to start getting ready for second hour. I don't know why they moved lunch. That's kind of annoying actually now, because everybody kind of knows my lunch. So if they want to make a plan for lunch, they know what time to start planning and all that stuff. Now I don't have that plan anymore. Anyway, I'm gonna go ahead and stop the video here. And I'll be ready to see you tomorrow on Wednesday. Again, you don't have to leave just yet. You can get all this down before you leave, but just make sure you get as much of it down as you can